Okay, we're back. So I took a few minutes to clean up the workbench. Might not be totally obvious, but there was a lot of stuff, a lot of wires left around from the build. And so another thing you want to make sure you get rid of are, see all these little bits and pieces of wire here? So you want to get those off the table because those could end up stuck in your circuit, short circuit things, and the things are going to go up in smoke, and then you'll have to build it over again. So we're going to test our circuit out now. So we're going to use the oscilloscope, and we're going to use the oscilloscope probes we were talking about in an earlier video. So these are switchable probes. They have a 1x setting or a 10x setting, and I want to put them on the 1x, and this is the attenuation. If I had it on 10x, if I had a 10 volt signal at the input of the probe, there would be 1 volt at the oscilloscope, and they do that so you can get higher voltage ratings. Like we know the vertical scale only goes up to 5 volts in 1x mode. If you have it in 10x mode, you can get up to 50 volts. But here we only need the 1x because we're dealing with circuits that are low voltage. So I have two probes. I plug one. I have one in channel 2 already. I'm going to plug the other one into channel 1. And what I want to do is simultaneously monitor the voltage on the oscilloscope on the output of the diff amp. I could use the witch's hat to grab the resistor, and I want to make a ground connection also here. And easiest way to do that, you can literally just put a capacitor with long leads in the board like this, and it kind of acts as an antenna or a piece of wire, and I can grab the ground, make sure I'm grabbing the right one. And it looks like this one. If I didn't, there'd usually be something crazy going on the scope. Okay, so you can see something crazy was indeed going on the scope, and now when I connected the ground, it calmed down a little bit. So we're out of range right now, that's okay. So we have our channel 1 turned on. So if the scope's out of range, I could tell it's above the top of the screen. So first thing I usually do is I just change the volts per division to a smaller value. And here we can see the trace. It's sitting at about 3.5 volts. That's what we measured on the multimeter before. That's a good sign. It's nice when your instruments agree. Now we're going to connect the channel 2 to the output of our integrator amplifier. And now I need to push the 2 button there to get channel 2 turned on. And we can see the channel 2 sitting way up high. It's on 100 millivolts per division. Bring that down. Now it's on 2 volts per division, and it's sitting at around 2.5 volts, as we expected and saw on the multimeter before. So now we could take some breaths and see if anything happens here. So remember, our gain's a lot lower than it was initially. And indeed, we see really not much. There's a little bit. You can see a little bit of wiggling going on the oscilloscope. And so there are a few things I could do. I could change the vertical scale, and as I do that, because the signal has DC offset, it's going to rise up on the screen. There are 2 ways to combat that, and the best way to do it is to just change the vertical position. Let's see, where did my waveform go? There, yes. And we know that we were offset by 2.5 volts, so I set the offset to 2.5 volts. And let's see if we could see any breathing now. And we could see some breaths on there. It's really buried in the noise. Like, that's not a very big signal. So, before we had to reduce the gain of our diff amp because of the offset problems that we were having, because we couldn't balance our bridge, and we determined that we lowered the gain on the diff amp by a factor of 10. Now we could make up for that loss of gain in the amplifier that's after the differentiator. So right now we just have a gain of 11, which is the 10K and the 1K. But if we up that to say a gain of 100, then we'd be in good shape. So I could take this 10K and change it to 100K. And that'll give us a gain of 101 times the 22, you'll get us back in the 2200 range that we needed.